The orbits of the 5 majestic outer planets of our solar system are unchanging and ever predictable. But there is other matter out there too. Millions of tiny planets, some the size of pebbles, some 600 miles across, circle the sun between Jupiter and Mars in the asteroid belt. NASA's Galileo spacecraft, on its way to Jupiter, sent back a photo of an actual asteroid in August of 1993. This is 243 Ida, an asteroid 32 miles long. Scientists believe that Ida was probably formed after the collision and breakup of a larger asteroid. The cratering on the surface shows that Ida has been struck repeatedly by other cosmic rubble. But not all of the cosmic rubble in our solar system is within the asteroid belt. Some bits of this space junk travel in wildly eccentric orbits that cross the orbits of the planets, including our Earth's. Though it's not very likely that a large asteroid will collide with Earth in our lifetimes, what if our luck were to run out? Perhaps the Hubble Space Telescope will warn us that an asteroid was headed for our planet while it was still a good distance off. But would that warning do us any good? World scientists would mobilize immediately and analyze the data beamed down from the satellites. Before long, the enormous asteroid would be clearly visible in the night sky, and all the great telescopes around the world would focus on it. Frantically, astronomers would calculate and recalculate its deadly path. They would measure the cosmic bomb's frightening dimensions: speed, 62,000 miles per hour, diameter, 12 miles, location of impact, East Africa. But we'd be helpless because all the instruments and all the scientific intellect in the world could do us no good. And it would almost be a relief when the arriving asteroid brightened the sky. And then it would disappear from the monitors. And with it would disappear human civilization as we know it. What sounds like a work of science fiction is not an impossibility. In fact, in December 1992, the asteroid Tutatis whizzed by Earth at 85,000 miles per hour, missing our planet by only 2.2 million miles, a near miss by celestial standards. Actually, many meteorites have struck Earth since it took shape 4.5 billion years ago. Most traces of them have since been wiped out by erosion and volcanism. Perhaps the most famous and best preserved evidence of a meteorite's impact is here near Winslow, Arizona. For a long time, this meteor crater was thought to be a dead volcano. In 1903, mining engineer Daniel Moreau Barringer studied the site to see if it might instead be a meteor crater. Though he did not find the meteorite, his surveys helped prove that it was indeed caused by one.
Many small planets cross the orbit of the Earth, and altogether there are about 2,000 of these small bodies that are larger than a kilometer in diameter, and the largest one, which we've discovered, is just a little under 10 kilometers across. Now, when one of these things actually hits the Earth, and they will hit the Earth, they have in the past and they will in the future, what happens is they produce craters, and a 1 kilometer diameter body will make a crater a little over 10 kilometers across, whereas a 10 kilometer body will make an enormous crater of almost 150 kilometers across. When a very large body produces a big crater, like 150 kilometers, it produces an environmental catastrophe over the whole Earth. Such a catastrophe happened 65 million years ago when more than 50% of the living species were wiped out.
65 million years ago, life on Earth lost its foothold. Dinosaurs had dominated terrestrial life for 150 million years during the Mesozoic era. And then suddenly, they disappeared, and there are no traces of those huge beasts ever having existed again. There is a sort of tomb for dinosaurs in Utah, the Dinosaur National Monument. So many dinosaur fossils and bones are preserved in the rocks of this former quarry that a museum was built around them. Many visitors come each year to marvel at the remains of those prehistoric creatures. Thousands of dinosaur bones have been found here, with at least 11 different species represented, enormous plant eaters as well as mammoth predators. Tyrannosaurus rex, the most powerful of all the predators, ruled over the rest of the animals that populated the fern forests of that period. Abundant vegetation nourished many different species of the huge plant-eating dinosaurs. Why then did this group of animals disappear from the face of the earth? The extinction of dinosaurs has been one of science's great mysteries. For 150 million years, they ruled the world, and then suddenly the fossil record ends. Although dinosaurs were the most prominent of the doomed animals, nearly 3/4 of the animals on Earth faced extinction at the same time. Fortunately for us, many species, among them the ancestors of human beings, did survive. There are nearly as many theories on why dinosaurs became extinct as there were different species of them. But the central issue is how rapidly it actually took place. Paleontologists are divided into two camps. There are those who contend that dinosaurs died out gradually, while others suggest there was a sudden apocalyptic end. The sudden extinction camp is further divided by what caused the mass extinction, a meteorite or volcanoes. Many scientists see evidence that a huge meteorite hit Earth, while others believe that volcanic eruptions delivered the fatal blow. The theories of a violent cause for their extinction have been romantic speculation for some time. Attempts to connect the dramatically appealing dinosaurs with an equally dramatic end. We do know for sure that dinosaurs and 70% of the rest of Earth's species died out at the same time. Was it caused perhaps by something that happened here on Earth? Geologic evidence shows that huge lava streams erupted in western India 65 million years ago, with thousands of volcanoes spewing ashes and dust into the atmosphere. Did these eruptions cause a domino effect, wiping out so many species? But there is also convincing recent evidence that it was prompted by an extraterrestrial event. Two geological discoveries suggest strongly that a meteorite was the cause. The first was in Italy, the second here in Denmark. Geologists have found in the rock formations of this coastline a thin layer of clay dividing the Cretaceous period from those that followed. These boundary clays date from 65 million years ago. Dinosaur fossils also date back to the Cretaceous, but not after that. Scientists have carefully analyzed this boundary clay. They bombarded it with neutrons so that any metal that might be in the sample was made radioactive and easily detectable. Using this process, scientists found that all the clay samples were enormously enriched in iridium, an element abundant in the core of the Earth, but very rare on the surface. Meteoritic dust, on the other hand, is highly enriched in iridium. Scientist Christian Kerbel. The enrichment of iridium in the clays dating from the Cretaceous-Tertiary boundary, together with other platinum group metals, suggests an extraterrestrial origin of this layer. Similar iridium enrichments have been found all over the world, on land and in deep-sea sediments. Most scientists agree that while volcanic eruptions could have released this iridium, such a vast global distribution could not have been caused by anything less than an extraterrestrial impact. Newer research here near Raton, New Mexico, provides even more support for the meteorite theory. In addition to iridium, the boundary clay here reveals another peculiarity visible only under a microscope. Shocked quartz. Normal quartz grains are smooth, but these have a parallel layering, a characteristic caused by enormous physical shock, the kind resulting from a meteorite impact. Through the discovery of shocked quartz at one site in particular, geologists now believe that they located the exact point of impact of the Doomsday meteorite. It is in the Yucatan Peninsula where they have found a crater over 150 miles wide and 15 miles deep, quite possibly the largest crater in the inner solar system. Even scientists who believe that dinosaurs died out more slowly accept the fact that their extinction was at least hastened by a meteorite scenario that goes like this. "65 million years ago, a meteorite struck Earth. Its diameter was about 6 miles, and it produced a crater 120 miles wide. The heat that was created by the impact surpassed that of the sun and set fire to more than 50% of the vegetation on Earth. Smoke from the burning forests, combined with the gigantic cloud of dust and vapor from the impact itself, covered the entire planet. Temperatures dropped, photosynthesis halted. It became winter, and the dinosaurs and much of the rest of animal life on Earth just froze to death. After the dust settled, the effect was reversed. Vapor and carbon dioxide in the stratosphere prevented heat from reflecting back into space. Temperatures rose enough to kill the plankton in the sea, and without nourishment, the large sea reptiles also perished.
Now, what are our chances that this is going to happen again? Well, we can calculate that fairly accurately. The chances of a 1 kilometer body landing and producing a 10 kilometer crater on the land, or a slightly larger crater on the water, there's about 1 in 100,000 per year. And the chances of our being clobbered by that giant object, the 10 kilometer body, making the very large crater, is only about 1 in 100 million each year. So while these things have happened and have influenced the course of evolution, our odds of being hit today or tomorrow or in your lifetime are not too great.
Even a small meteorite can cause an earth-shaking blast.
Hurtling through the solar system, a speck of cosmic dust strikes the Earth. Commonly, these meteors are vaporized by friction in the atmosphere. This is part of the story of one that wasn't. A meteor that landed in 1908 in Siberia near Lake Baikal with the destructive force of an atom bomb. Over half a century later, a 20-mile area around the vast crater is still seared and battered. This recent Soviet expedition succeeded for the first time in locating fragments of the original meteor, only tiny particles remaining of the original mass of rock and natural steel, whose impact was recorded by scientists as a major earthquake. It terrorized natives of the primitive region. Another link in a remarkable chain of evidence to solve the mystery of the Lake Baikal explosion, literally a catastrophe from outer space.
Meteorites are as old as our solar system and were created in the same process as the sun and the planets. $4.5 billion years ago, a huge cloud of gas and dust accumulated on the outer borders of our Milky Way, the remainder of an enormous exploding supernova. Gravity first turned the cloud into a flat rotating disk, the solar nebula. As it gathered speed, it pulled in more dust and gas, and the core increased in mass. Dust particles began colliding, forming solid bodies. While rotating around the core of the hot disk, the larger bodies at the edge of the solar disk collected even more matter and eventually formed the protoplanets. Under the crushing gravity of its enormous mass, the core of the solar nebula grew so hot that nuclear reactions ignited the sun. The young sun's intense radiation accelerated the remaining gas and dust, and this solar wind carried the particles out of the solar system. The gravity of planets of the inner solar system began attracting smaller bodies, and their mass increased through numerous meteorite impacts. The planetary surfaces were turned into lava as the energy and heat of the impacts melted and thus reshaped them. The constant meteorite bombardment eventually stopped, and the planets cooled off. Any impacts that followed struck a solid surface and gave the planets their final shape. 9 planets orbit our sun. Furthest away is Pluto, a ball of frozen gases. Then come the 4 gas giants, and then closest to the sun are the 4 terrestrial planets. The division between the inner and outer planets is marked by the asteroid belt, the junkyard, so to speak, of our solar system. But other asteroids also exist too. They travel in their own orbits outside of the belt. All asteroids are irregularly shaped stone or metal objects and are thought to be the debris of a planet that never formed. When an asteroid gets caught in Earth's gravitational field and survives the fall through our atmosphere to strike the ground, it is then called a meteorite. There are 2 distinct classes of meteorites, differentiated and undifferentiated. Differentiated meteorites are those that have separated into internal layers according to their densities. This one is called an iron meteorite because it is 90% iron and 10% nickel. When cut and etched, its remarkable interior structure becomes visible. This is called a stony iron meteorite because it has silicate minerals in the metal. The third kind is called a stony meteorite. Undifferentiated meteorites are the second group and contain chondrites. Geologist Gero Kurat.
Die bei weitem häufigsten Meteorite sind die Chondrite.
Chondrites are the most abundant meteorites. We call them chondrites because they contain a large amount of chondrules, or molten droplets which solidified. Chondrites consist of chondrules and aggregates which are similar to each other and set in a fine-grained, dusty matrix. Chondrules, or droplets of fiery rain, as they were once called, can be seen under the polarizing microscope. This protomatter, which never totally melted, provides important information on the birth of the solar system. Because so much evidence of meteorite impacts has been lost over time due to Earth's changing landscape, Arizona's meteor crater can be considered a true cosmologic museum.
This event has produced for us one of our finest laboratories on Earth to go and study what happens when a planet hits the Earth. And it's here that we first discovered the high-pressure minerals that allowed us to go and identify other, still larger craters elsewhere in the world.
Researchers use information from the crater to piece together the impact process. At NASA's Ames Research Center, scientists can simulate impacts by using a 6-floor-high acceleration gun that fires metal balls at 25,000 miles per hour into a sandy target. The impact is filmed in extra slow motion. Melted sand is ejected, and the projectile is completely vaporized, leaving behind an impact crater. This experiment shows in miniature form just what happened in Arizona's desert 50,000 years ago. Computer models of meteorite impacts show us individual phases in the formation of craters. Surface rock and the meteorite itself melt or vaporize upon impact and send a shock wave into the ground. The rock then decompresses and a reverse wave moves to the surface, and melted and shocked stone is pushed out. The matter falls back in. The resulting crater is dramatically bigger than the original projectile. The messengers from outer space provided ancient high cultures in Mesopotamia and Egypt with the heavenly metal iron long before humans learned to exploit the ore on Earth. How the ancient world used the heavenly metal was uncovered early this century. In 1922, archaeologist Howard Carter made a major discovery after a 20-year search for Egyptian antiquities in the Valley of the Kings, where one last royal tomb was thought to remain. After breaking through several walls and doors, he found himself in an antechamber containing numerous burial objects. Had grave robbers gotten here before him? Carter held his breath as he opened the doors to the shrine. And then he saw it, Tutankhamun's sarcophagus. Carter's were the first eyes to behold this precious sight in more than 3,000 years. When he unwrapped the bandages of the mummy, Carter found a total of 143 objects. Among them, a dagger whose blade, in all probability, was made of meteoritic iron. It had been a present for Egypt's ruler from the Hittite king of Mesopotamia, and was 4,000 years old. In Greece, the messengers of the gods were also received with much honor. Temples were built for them, and they were immortalized in coins. The Romans, too, made meteorites the objects of divine worship. Caesar's death was even supposedly announced by a meteorite. Cosmic debris is also thought by many to be the cause of one of the most well-known celestial happenings in the history of Western religion. This is the sky at the birth of Christianity. But the star of the Magi is not believed to have been either a visitor from outer space, nor a comet, nor even a meteor, as this famous mural by Giotto suggests. Astronomers can find no evidence that a star went supernova at the time. The leading contender as the cause of that ancient happening is the once in 900 years conjunction of Jupiter and Saturn, which was recorded by Asian astronomers in 7 BC. When observed from Earth at that time, the two largest planets of the solar system might have appeared to be next to each other in the sky, and could have looked as though they were moving together. During the Middle Ages, comets were considered God's punishment, portending epidemics, wars, and bad harvests. Ordinary people looked upon these mysterious visitors from outer space in awe and superstition, while some early scholars began to investigate their nature. In 1682, English astronomer Edmund Halley not only observed and predicted the orbit of the comet that bears his name, but he was convinced that it had been seen many times before and that it returned to Earth every 76 years. Halley was ridiculed by his contemporaries, and only when his prophecy came true in 1758 did the ridicule cease. In 1910, millions around the world witnessed Halley's comet, and it was actually photographed for the first time. In 1986, scientists conducted an even closer investigation of Halley's comet. 5 separate spacecraft were sent into space for a close-up encounter. When the rocket Ariane 1 embarked on its rendezvous mission on July 2, 1985, it carried the spacecraft Giotto, which was intended to get closest to Halley's comet. On March 14, 1986, Giotto was only 370 miles away and sent back the first ever images of a comet's nucleus. A comet originally was thought to have been the cause of the famous 1908 explosion over Siberia, with the force of 1,000 atom bombs. However, scientists are now fairly confident it was not a comet, but a meteorite. Comets originate at the Oort cloud, out at the very edge of our solar system. Periodically, clumps of ice and dust are dislodged from their distant orbits and fall towards the sun. As they swing by, the ice and dust evaporate and are blown back by the solar wind to form the comet's tail. Mass extinctions on Earth appear to occur every 26 million years. To some, this suggests that our sun might have a distant dark sister, Nemesis, which could sometimes interfere with the orbits of the comets and send them on a collision course with Earth. If this theoretical Death Star actually does exist, there is no need for any of us to worry for a very long time. Nemesis would not be due to return for another 15 million years. An average of 2 asteroids are seen to pass near our Earth every month, while tens of thousands of meteorites actually strike Earth each year. But this is only a fraction of the cosmic debris that rains from the sky, because most of it burns up in the atmosphere. Sometimes these burning meteors can be observed. A Lufthansa crew witnessed one such fireball at a height of 33,000 feet. Their cockpit was suddenly brightly illuminated, but no trace was ever found of the meteorite on the ground. Another sighting occurred in Upper Austria in 1932. One night, rolling thunder woke the inhabitants of a small town, and many witnessed a fireball lighting their sky. The next day, this 4-pound stone meteorite was found, allowing the witnesses to this cosmic incident to feel at least a little rewarded for their scare the previous night. We were standing in front of our house, and then somehow saw that streak of fire. Of course, it suddenly disappeared. Then there was this rumbling sound, and it hit the field. We were on our way home, and then there was this dreadful detonation. And when the light spread, the entire village was illuminated, so that one could see every rabbit, even mice running. Even though the meteorite was so small, the fireball was seen from 250 miles away. Fragments very similar to the one that amazed those Austrian villagers are scattered around the globe. 80,000 years ago, a heavenly stone came to Earth in southwest Africa. The huge fireball in the sky, the rolling thunder, and the force of the impact must have terrorized animals for miles. The world's largest known single meteorite was discovered in 1920 at the Hoba farm in present-day Namibia. The Hoba meteorite can still be found where it hit the soft limestone centuries ago. Despite its mass, it was small enough to be slowed down by the atmosphere, which prevented it from producing an impact crater. The Hoba weighs about 60 tons. Namibia's government declared it a national monument in 1955. That is fortunate, since the meteorite would surely have brought a tidy sum in the marketplace. Within it are 50 tons of iron, nearly 10 tons of nickel, and more than 900 pounds of cobalt. The Hoba is rightfully recognized as a precious treasure. In Namibia's capital, there is even more cosmic material to be seen by residents and tourists, the many fragments of the Gibeon meteorite. This meteorite fractured when it entered the atmosphere and produced the largest meteorite shower in recorded history. Today, the majority of the Gibeon fragments are exhibited in the capital's pedestrian zone. Altogether, 28 fragments were found, weighing between 7 ounces and 140 pounds. Their combined weight totals 21 tons. From the surface, we can view meteor impact craters only from limited angles, but satellite pictures provide different and fascinating views. This satellite picture is of the Clearwater Twin Crater in Canada. And this is the Gosses Bluff Crater in Australia. While Namibia's Gros Brucaros is known to be the remains of a collapsed volcano, its Rotterdam crater is a perfect example of a meteorite crater. And this is a satellite view of Meteor Crater in Arizona. Caused by a meteorite 100 feet in diameter, Meteor Crater is 4,000 feet wide and 500 feet deep. It is so big that New York's St. Patrick's Cathedral would disappear in it. Ancestors of Arizona's Indians more than likely witnessed the enormous impact that caused Meteor Crater. To those Indians, the crater has always been a very special place. Their legends tell of a god coming down from heaven, accompanied by thunder and lightning, and burying himself here. The crater has been sacred ever since. That explains why, when mining engineer Daniel Barringer tried to find meteorite fragments here in 1903, the local Indians refused to help him in the search. The American prairies have also been showered repeatedly by meteorites. To Native Americans, the falling heavenly stones were imbued with supernatural powers. One tribe of Comanches, after a vain attempt at melting an iron meteorite, came to revere it and placed it in their medicine man's teepee. These inaccessible canyons in the Four Corners region between Colorado, Utah, Arizona, and New Mexico witnessed the development of North America's sole high culture since the 3rd century. They were called Anasazi, the Old Ones, and were forebears of today's Hopi Indians. Their ancient Pueblo city, shielded from the elements by this cliff above, clings to the steep walls of the canyon like a human honeycomb. Why the Anasazi left Mesa Verde in about 1300 is still a mystery. They are known to have been excellent astronomers. At the center of their religion was the sun and a meteorite. The 8-pound iron meteorite found in this sun temple in 1922 was probably worshipped as a messenger of their sun god. To the Anasazi, faith and everyday life had to conform to the universe. Paintings depicting this belief are found all over the stone walls. The sun is ever prominent in their drawings of plants and animals. To the Pueblo Indians, meteorites were not thunderstones foreboding epidemics and bad harvests. They were instead revered as gods descending to earth. The Indians were fascinated by the myths of the meteorites. To them, the iron stones from the sky were indeed divine. They were even buried as gods. In 1928, a meteorite was discovered buried in this tiny stone tomb in northern Arizona. Even if the rest of the world does not share that divine perspective, we cannot help being fascinated by these messengers from outer space.